and in this tutorial we're going to discuss the recent changes I've made to the project. You do not have to include these in your project, particularly if you've developed a lot of code and you've diverged a lot from the original version of the project. The main changes here are to help you with range queries in Lucene. I've also replaced the peer ID with from being a big integer to being a long, and the peer address and peer message I've pretty much ripped out. So they're the main changes that have been done. I've also added some small piece of code to help you with things like writing a comparator to implement the gradient, and how to help with partitioning up of the index. So how to generate a routing table for the different partitions. Okay, so let's have a look at the changes that I've made. We can see them here on the commits in GitHub. So you can see the most recent, or the commit that was actually made here was May the 5th. And there's a comment saying, let's read the comment. Removed peer address, peer message, range queries of Lucene index implemented in search component. Added messages to for request and respond messages with missing index entries. So that may be a slightly cryptic comment. Basically what I did was I added a request message and a response message to the search component to allow you to say, oh, I'm missing these index entries. And finally then there's what you call a leader emulator. So if you have not implemented the gradient yet and your leader election algorithm, you can use this singleton just to emulate what it would be like to have a leader in your project. And obviously you should replace this at a later stage with a leader election service based on, for example, the gradient. Okay, so let's look at some of the changes. They're quite extensive. I can see firstly to start out with, there was a big mistake. There's a target directory included in Git. It's actually, no, we've added one to Git ignore, sorry. So let's just go through them. So the first file here is the configuration file. Yeah, so I made some small changes to the configuration file, renamed aggregation configuration to search configuration. That's not a big deal. We've replaced, as I mentioned already, replacing big integer for the integer ID with a long value. So this is the long value here, and that propagates all the way up to the experiments, the simulation scenarios. Okay, so you can see that big int change is propagated to cycle and configuration. Search configuration, we have quite a few changes here because we have a couple of new parameters here. I've added a number of partitions, as when I discussed in class last day. One potential way of partitioning up the index is to have a static number of partitions. And if you have a static number of partitions, you'll need a routing table to be able to route your search requests to those different partitions. And in that routing table, you'll need potentially a maximum number of routing entries within that table. So these are just configuration values you can set at your experiment level, and then they'll propagate all the way down to the search component. Here we can see join peer. We've the join peer event is created in the simulation scenario, and we've replaced the big integer with a long for a peer ID. And the peer address, again, we've replaced, actually, sorry, yeah. So the peer address I couldn't remove entirely because peer address is used by the Bootstrap server. So what I did was I pulled out the peer ID, the big integer peer ID, because it's not really necessary for the project. and we're left just with a wrapper class. The peer address is just a wrapper class which contains the actual, this line here, the address of the peer. Peer message has been removed. So the change from big integer for the ID to long has repercussions here. In add index entry, we have some changes. Peer fail, peer join. Similarly in operations, changes. Scenario 1, you can see. Scenario 1 is, I guess scenario is interesting in the sense that previously we were generating a big int from a uniform random distribution, size 2 to the power of 13. In this case, we're now generating a peer ID in the range 0 to integer max. So as you may guess, then we don't need to keep well, we're creating it as a long. And the reason we're doing that is because Compix currently supports a method to generate uniform longs. It doesn't support at the moment any method to generate uniform ints. So I decided I'd go with longs, and the longs would be generated in the range of 0 to integer max value. So if we want to, we can cast the long value to safely cast the long value to an int value further down in our project. So somewhere like the search component, if we get a long in, we'll know it's an int, and we can safely cast it. So keep going down. So cycler simulator, the big int change has some roll-on effects there. Graph util as well. Peer info. Again, we're only in Cyclone, so these are just changes that propagated out from the big int to long changes. Removing peer address and replacing with address also propagates into the Cyclone component. And yeah, we can see the same here. So it's all really just replacing peer address with the normal address. And the same here. Again, peer address replaced with. So this is when we get down to firstly where we replaced peer message with message. So all we did was, instead of inheriting from peer message, we can inherit from message. And where we had a peer address, we have an address instead. So nothing else here. Okay, this file search.out most definitely should not be checked into Git. So we should remove that. Search simulator. Okay, so now we're getting up to our search component. So in the search component, you can see here that where we had previously a map of big integers component and big integers peer addresses, now we have a map from long. So this is the reference of the components or peers that get created. It's a map containing the ID of the peer and its actual component, its Compix component, and the ID of the peer and its address. So replace the peer address with the address and their big integer with long. We don't need a peer ID sequence, which we had before, because the IDs are being generated in our experiments. So the peer IDs are being generated in experiments. Previously, we had peer ID sequence in that every new peer that was created would get a monotonic increasing ID. In our case now, we're just generating uniform random identifiers for peers. There is a check in the code to make sure that that peer IDs don't clash, and it's done using this consistent hash table. Okay, so let's drop down in here. Okay, I guess this is new. It looks like new code. Yes, the web request. So this is a small change. So when a web request comes in, we're looking up the peer ID for the ID of the request that comes in. So you can write a random ID in when you're running the program and you want to send a web request to a peer. You can write in a random ID. It will then find the successor peer ID on the ring, get that component, and send the web request event to it. And then the web response gets forwarded through here. previously we were connecting up the web port of this Cyclone simulator with the port of the search peer. But I think we're not doing that anymore, because what's happening here is that this particular web request is filtering out. It's saying this request is destined for this host, for this particular peer. Previously, I think we had a filter on the connection. Okay, so there's not really, most of the rest of the changes relate to replacing peer address with address and big int with long. Okay, and same here. Search peer. No, it's the usual. Okay, so the only place we have in, you can see here that I've wrapped the peer address with, sorry, the normal address with the peer address. So when we bootstrap, we need to use peer address. So that's the only place I think it's continuing to be used. Okay. Get updates. Okay, that was okay. Okay, yeah. So to support range queries, I added. We made some changes. Yes, we changed the index ID from being a string to being an int. So now we have a representation of an index entry as being an index ID, and then the actual text for the searching on the values. So missing index entries is a way of asking your neighbors from the search component, please send me any missing index entries in this range. So we have the notion of a range class, and you're saying these are the set of ranges I'm missing, and you'll get a response with a list of index entries. So let's look at what a range is. Dimitri wrote some code which I just refactored. Thanks, Dimitri, for the contribution. But basically, a range just has a lower value and an upper value. And in the actual search component, this is where we have a lot of our changes. What we can see is